Welcome back to week 9 of History of Industrial Design. Normally this is a 2-week, 3-part investigation into mid-century design. But this year it's going to be a 2-week, I don't know how many part investigation. I'm trying to make it smaller bits, and I'm using the opportunity to clean up the narrative by pulling some things out. So this week is the history of plywood and the work of Charles and Ray Eames as 2 separate but related conversations. And then next week we'll look at designing for the home and the office. There was a really strong form language in mid-century America. Why did that happen? Where did it come from? One reason is that for this whole semester we've been looking at how designers were striving for manufacturability. How do you make things in repeat in large quantities using a machine, but still have some control over what they look like? And World War II really helped advance technologies in many ways that helped us sort of gain control of the machine. And for the first time, really since the Industrial Revolution, produce shapes with intent that we wanted to be making. And another factor is the development of new ideas about housing and a new understanding of the home, and also a new presence of corporations and offices in our daily lives. And that's what we'll look at next week. My weekly disclaimer is there are a lot of chairs. There are 3 weeks this semester with a lot of chairs. The Bauhaus and tubular steel, plywood and the Eameses, and then plastics. Don't think of them as chairs. Think of them as investigations of new technologies and materials. Because this week is all about material investigation, in this case plywood, as a door into creating a new aesthetic. The story is best illustrated by one of the most iconic objects from the period, the Eames plywood chair. But we have to look at all the things that let this happen, and then all of the things that it influenced after its arrival. This is the ultimate expression of where plywood can take us. This is a sculpture that Ray Eames made while experimenting with the limits of where plywood could go. But that's not where we start. First, we have to look at the larger conversation that plywood represents, which is how do you take this thing called a tree and turn it into something it didn't know it wanted to become? Nature makes trees for a bunch of reasons that I don't understand, because that's biology or ecology or some other ology that I don't speak. But we then cut down trees, dry the wood, and make them into stuff. That's not what nature intended for the trees. And in the process, we run into the limitations of wood. It has grain, it's alive, it moves, it swells and shrinks. And the limitations of that wood have to factor into how you make things. So throughout time, we've run into the limitations of wood and looked for ways around them. In ancient Egypt, there were not forests of huge old-growth oak trees to be made into furniture. The wood that was available was smaller. So any larger furniture had to be made by laminating wood together, and the Egyptians had a lot of techniques for gluing wood up into larger pieces of wood. And if you're making a bowl or a large vessel out of wood, you'll have an area of short end grain where it will break. And then as the wood expands and contracts, the bowl will most likely crack open. There is evidence in ancient Chinese burial sites of barrel lamination or cross-grain lamination bowls where rectangles of wood are glued together and then the bowl is carved or turned. So in the end there is no short grain, there's no end grain, and the whole piece will move consistently because all of the grain in this bowl is the same. This is a technique we already encountered when we looked at the work of John Henry Belter. This is the pinnacle of this type of work. Belter mastered what we call cross-grain lamination, so taking solid wood and gluing up pieces with each layer changing the direction of the wood grain, and you get something that has strength in any direction. And that's what allowed Belter to carve this wood out of recognition, so it no longer looks like a board or wood, it looks like bunches of grapes. And if that happened out of solid wood, they would all break off. There would be all sorts of weak spots throughout this. Belter did also use plywood in some of his furniture, but the work he's best known for is this highly carved, cross-grain laminated furniture. Wood is inherently malleable. If you cut a thin piece of wood, you can bend it around. And there are a number of examples of people trying to invent new manufacturing methods to take advantage of that malleability. The Grag chair is made of thin strips of wood that are steam bent into shape and then sort of caged. They're all assembled with joinery into a structure where they can no longer move. The chair is called the elastic chair because it has some flexibility as a result of being made up of such thin pieces of wood, but it also has structure because of the way they're all combined. We already looked at Thonet's extraordinary success with his steam bent chairs, like the chair on the right. This is wood that was infused with steam until it was pliable and then bent into shape until it dries, and turned into a new form. That's a great example of wood transcending the limits of what it was intended to do through careful investigation of what it could do. But that isn't where he started, and I mentioned this when we looked at his chairs. He actually had an earlier chair that was comparatively a failure. That's the chair on the left, the Boppard chair, which is not solid wood. This is laminated strips of wood, thin strips of wood that are pliable, glued up together and clamped in place, and when they dry, they come out of the mold rigid. The problem with this chair is that the glues available to Thonet were all water soluble. They were casein glues or blood glues or hide glues, and so when he shipped a batch of these chairs to South America, a very humid environment, they fell apart. That failure led him to create what we know of as the Thonet chair, but even that early investigation provided some really interesting techniques that have stuck with us and are still the foundation for how we produce laminated wood. On the left is a section view of some of the clamps used to produce the remarkable shapes that make up the Boppard chair. Just as an aside, Thonet's family continued these investigations. His son August experimented with what we would call a single-piece chair. The chair on the left is one board. It's one piece of wood that's been cut and then steam bent into shape. So to help you understand how that works, on the right is a piece of furniture made by a contemporary woodworker working in the same vein. His name is Mike Jarvi, and he makes these benches. So the schematic on the top shows you how Jarvi takes a board and cuts it, I guess with a bandsaw, and then steam bends it open into a one-piece stool. It looks like it has multiple parts, but it's just one piece of wood. And that's what August Thonet was also exploring. The most remarkable example of this is so hard to explain. I'll try, but I know that I'm doomed to fail this one. On the left and right are photographs of the chair, and in the middle are production models to show the technique. So the leftmost of those is the board that's been cut into profile and then also sliced into sort of fins. And the second one from the left, then, it's been steam bent around and joined in the middle. So now you have the back of the chair and the back legs. And then it's steamed again, and the seat and front legs are pulled up and forward. And the internal structures are bent into place and combined. That entire chair started out as one board and was heavily manipulated to become a chair. This, of course, was so fussy and difficult that it didn't go into large-scale production, but it's a really beautiful example of the determination to explore what else wood fiber could be. The idea of plywood is part of this larger conversation about trying to improve wood. It's so arrogant, right? Like, wood's okay, but we could probably make super wood. Veneer is really old. For centuries, we used it as a way to put a fancier wood like mahogany or ebony on top of a cheaper wood like pine. And it was made, as you can see in the picture on the upper left, by taking a log in a vise and then taking a saw back and forth over and over to slice it into many, many thin sheets of wood. That got scaled up during the Industrial Revolution. Add a power source to that and you get wider logs, thinner veneer, more even surfaces. But it's still wood being applied to thicker solid wood as an artificial surface. John Mayo filed a patent in 1865 for something he called a scale board cutter. And this was essentially like a hand plane. It took a blade and then just rammed it into a log and shaved off a piece of veneer. He then proposed that these would be cross-laminated, turned at different directions and glued together to make something called a scale board. And the patent description says, scale board is made by cementing or otherwise fastening together a number of these scales or sheets with the grain of the successive pieces running crosswise. He didn't do more than patent this idea, but he had the idea of plywood and got the word out. And we start to see people experimenting with this idea of taking veneer and changing the grain direction and making a new material. Isaac Cole filed a patent in 1873 for a one-piece chair. This is meant to be layers of veneer glued up in a mold to produce a chair. He only ever made the patent model. It's a miniature version of the chair. But again, it's someone realizing that there's other opportunities with veneer than the world had realized so far. And so plywood started to arrive in the 1870s as a manufactured material being used in things. Mostly it was used hidden, inside furniture, beneath upholstery, for something utilitarian where we didn't care what it looked like. And when it was used in a visible way, it was used as a novelty. The Gardner Chair Company from New York is a great example of a company that realized this new material was interesting and could provide part of the surface for a chair. At the same time, it couldn't have its own integrity. It had to be decorated with drilled holes in crazy patterns. So there's all sorts of decorative motifs that are applied to the plywood to sort of make it palatable or acceptable. Their catalog is full of endless versions of chair structures with a decorated, perforated veneer seat. And they were really popular. The picture on the right is from the catalog of the Centennial Exposition in Philadelphia from 1889, and it just shows a mountain of all their different styles of chair. And the catalog just has page after page after page of chairs that look to our eyes almost identical, but at the time were sort of rich variety of different styles. And look at the crazy benches on the right where they use drill holes to make patterns and spell out words. So we've got Our Sabbath Home, Friendship, Love and Truth, and Visit the Sick. I have to wonder where that last bench was used. Airplanes and plywood arrived at about the same time, and it's a really good combination because airplanes need to be light and strong, and molded plywood could do that. When you have compound curves, a surface that's bent three-dimensionally, you have something that's much stronger, like an eggshell, with a thinner surface and less material. At this point, though, the airplane shell was a monocoque construction. It was one surface, but it was completely handmade. Thin strips of veneer were fit together by hand and attached to the mold. So it was a pretty high-end craft project that allowed this to happen. One of the biggest early uses for plywood was actually Singer sewing machines. Both the tables and the cases were among the earliest uses of plywood in production. They called it layered wood or built-up wood at this point. Singer was selling 3 million units a year by 1900, most of them with a plywood component somewhere. What we think of as plywood, though, real plywood manufacturing, had to wait for 3 advances. So there are 3 things you need to make plywood. And this is evidence of the first thing you need for plywood. You need veneer. Not thin slices of veneer as wide as one log, but an endless long piece of perfectly even wood grain that you can cut into any rectangle you want. So the log is put into the machine, a blade is slowly run into that rotating log, and it trims off the outside and turns it into a cylinder. So the first thing the machine does is rationalize nature and make a cylinder. And once that happens, the blade then just cuts an endlessly long, perfectly thin, pliable piece of wood that's rolled right back up. So it's kind of a crazy equation. We took this thing called a tree, which is mostly a cylinder, unpeeled it and rolled it back up. So it looks in the end pretty much like it did when it started, but it's been completely, I don't know, transmogrified, if you want to use a 25-cent word. So that's the first thing plywood needs. It needs veneer. The second thing it needs is glue, a resin-based glue, not a casein glue, which is milk curd, or a blood albumin glue, which is animal blood, or a hide glue, or glue made from hooves. Nothing from nature. It needed to be a waterproof resin-based glue. And this arrived with Leo Baekeland when he invented Bakelite. In 1912, when he was able to produce Bakelite, but he didn't have much of a market for it, he approached the plywood industry and recommended using Bakelite as an adhesive. We looked at Bakelite in the Art Deco era because all the new telephones were being made out of Bakelite and other phenolic resins. At this point, it's really transforming manufacturing as well. And then the next big step forward was 1934, when Dr. James Nevin, who was a chemist at Harbor Plywood, developed a fully waterproof adhesive made of phenylformaldehyde, and that's what we still use for most plywood. So the first thing you need is veneer, the second thing you need is a waterproof permanent glue, and the third thing you need is heat and pressure to clamp your plywood in shape while it dries, either flat or in some molded configuration. That's an old technology. The Egyptians used hot sand in bags to weight wood down while it dried. In the 1700s, we started to get screws so we could make metal clamps. And then in the 1890s, Christian Luther, who was one of the pioneers of plywood construction, developed the hydraulic hot plate press. In the upper right, you can see a fancy version of that. It's a mold that has metal on the surface, and you can see a wire going to it that's running electricity through that surface so that it's heated. So then when the mold closes, you get even pressure and heat, and you've got plywood. With those 3 things in place, the age of plywood was upon us. At first, it wasn't really accepted. It was called veneer stock or pasted board, and it was dismissed as dishonest and something inferior to solid wood. Where plywood was accepted was for non-decorative functional items, because it could make them cheaper or lighter or more durable. If it's going to cost me less and last longer, I don't care what it's made of. By 1885, plywood canoes were being made, and they were really popular by the 1920s. In 1917, Haskell Canoe was able to make one canoe every 20 minutes. This is a hilarious ad for Haskell Canoe that disproves everyone's skepticism about it being too fragile to be strong by showing 3,420 pounds of weight in this and on this canoe and saying that it flexed a mere 3/4 of an inch. And there were other utilitarian applications for plywood happening at this time. Panels for cars, whether painted out or left visible, and also luggage. So anything that needed to be durable and lightweight might be reconsidered with plywood. And with the new veneer, the monocoque construction of airplanes could be revisited. I love the conceit of proving how light a plywood airplane body is by having one person hold it up. You rarely can see what's happening out of the frame where the other end of the airplane is. But still, you get the point. It's a lightweight construction. These are still made with two-part molds, a concave shape full of sandbags to clamp the wood in place, or a two-part mold that's fitted and clamped shut. It wasn't until World War II when Jean Vidal introduced the vacuum bag, a flexible plastic bag, that we could make more complicated shapes. But the shape of a basic airplane is simple enough that it could be made with plywood in large quantities. Lockheed Vega was one of the first companies to realize that, and in the 1930s, the Lockheed Vega arrived at 185 mile/hour cruising speed. It was a single-bodied plywood hull, and it's the kind of plane that Amelia Earhart flew from Los Angeles to Newark, making her famously the first aviatrix to fly nonstop across the continent. Wood wound up falling out of favor for airplanes because we started to conquer aluminum, and we could make something that required less handwork and was lighter and more durable. But we'll revisit that story when we get to the war. Now let's look at how plywood became useful in other parts of design. And this is where you may get annoyed with all the chairs. Josef Albers is super important in the investigation of plywood as a material for furniture. Early in his career, before he found plywood, he designed wooden furniture which explored material potential and modern style. Wood should look like wood. In this case, it should look like a plank, because what we do is we cut down a tree and we use machines to cut that into rectangles. So Albers' idea was, let's leave it as rectangles and see what compositions we can make in 3 dimensions. You all know Josef Albers from art history because of his paintings. He was the titan of color theory, taught at Yale, and it's a great relief to me to realize how late in his life this success happened, because I still have time. You also may remember him from your reading about the Bauhaus. He designed the famous tea glass for the Bauhaus, which is a symphony of geometry, of circles, and it's glass and metal and everything you want from a Bauhaus object. He worked mostly at the Bauhaus, though, in fine art in the glass studio using etched and tinted glass. As an aside, Annie Albers, Josef Albers' wife, wasn't allowed to work in the shops in the Bauhaus because she was a woman, so she went into the textile studio, and her textiles and his glass look pretty similar. I'm just saying. Albers was also working on designing furniture that expressed that same modern sensibility, but with different techniques. His are really the first modern bent wood chair investigations since Thonet's in the 1850s. Thonet invented a whole new aesthetic by looking at what wood could do. Albers' chair on the right is laminated strips of wood to make the side pieces, and it creates a whole new look for a chair. It looks very much like the tubular steel chairs at the time, but using wood. Throughout the 1920s, because plywood was starting to be more visible, we start to see a bolder exploration of what plywood could do. And Gerrit Rietveld, whom you know from his zigzag chair, there's one at the RISD Museum, was also interested in having form reflect the fabrication techniques and the materials. And throughout his career, he experimented with new materials in chairs, bent metal tubing and formed plywood. I have a really clumsy metaphor that I've had to use for the last few years because no one's helped me think of a better one. So I guess I'm glad this is going public because maybe someone out there who isn't one of my students can help me come up with a better metaphor. This is a taco. Look at the chair on the left. All the bends happen on one axis. So it's layers of flat veneer pressed into a mold to make a new shape, but all of the bends are on one axis. What we're going to look at in this investigation is the struggle towards the potato chip. How could you layer wood together so you can bend it in multiple directions at once? Right now, we still have something that's very geometric because it's flat planes and momentary bends. We want to work towards something more organic by bending it in multiple directions at once. So this is a taco. We're going to keep looking at tacos for a while and work our way towards potato chips. Really clumsy metaphor, but I still stand behind it because it works. Just as a side note, Rietveld had a really long career and just kept designing new things. I'm only showing you this chair because it is another example of a plywood chair, and it's also an example of someone really struggling to see what he could do with a taco. These are all separate parts bent on one axis, combined to give the impression of multi-axis changing of directions. But he didn't really, in his career, have the ability to get past the taco. Keep this chair in mind when we look at what Charles and Ray Eames accomplished. The next really important chapter in the development of plywood in designed objects involves Alvar Aalto, the Finnish architect and furniture designer. He studied architecture at the only school of architecture in Finland, which at the time was still a very new country, and was active in helping define the national identity and style as an active design effort. His architecture is among the most defining aspects of the Finnish aesthetic, but his furniture, mostly designed for use in his architecture, really helps advance the story of plywood. And if you look at this picture, you'll notice there's an arm sticking in from the left. That's because the figure on his left is his wife, Eino Marcio Aalto, who was also a trained Finnish architect, certified in 1920. And she went to work for Aalto in 1924. They were married in 1925, and she had a short life. She died of cancer in 1949, which cut her career short. But even more than the shortness of her career, they worked together in the office. And so a lot of his architecture work was done with her, in conversation with her, and her work has, for the most part, disappeared into the background. He's the genius who gets credit, but she was there throughout all of it. And I'm not so interested in teasing out who did what. I just want to make sure you're aware that behind every single accomplished person is a team of people who helped, and in this case, a really remarkable early female architect. Her independent work, the things we do know that she did on her own, is really lovely. She did textiles, she did ergonomics investigations, she designed glassware. So what was her role in their office output? I leave that to your imagination. There are some things that are credited to both of them. One of those is the very famous Savoy vase on the right. And on her own, she designed a line of glassware for Chalr, which has been in production since 1932. You may recognize it because it's still made today. You may also sadly recognize it because IKEA has been selling a knockoff version of it for years. Aalto's furniture, which is happening at the same time as all the tubular steel investigations we looked at with the Bauhaus, is using old materials like wood to define a new aesthetic. So he's arriving at modernism and a new aesthetic without changing the techniques much. His work is so unlike other modernists at the time. As a result, it has the warmth of wood instead of the coldness of metal. This first chapter of what plywood can do is clearly seen in his furniture investigations. He set up his own office in 1923, and his most famous building on the lower right is the Paimio Tuberculosis Sanatorium, built in 1932. It brought him to international fame, and that's talked about in an architectural history class for a long time. We're going to look at the furniture he designed for this building. Almost all of the furniture he designed was designed for this building. And like Corbusier and Perriand and Jeanneret, who were looking at different seating positions and trying to make furniture that matched, all of the furniture for the Paimio Sanatorium was designed for different specific uses: relaxation, doctor's office, visit. But notice again that this plywood is bent. It's not molded. Bent plywood is a taco, molded plywood is a potato chip. But these are really beautiful forms, considering that all the bending is happening on one axis. Aalto was also really adept at combining sheet plywood with laminated structural components. The side pieces or leg components are laminated strips of wood, and the central components are veneer glued up into plywood. If you ever get a chance to examine the structure of these up close, do so. Aalto worked with woodworkers who arrived at really beautiful structural systems to combine the thin plywood and the thicker side members without needing especially fussy joinery. And yet, that's all sort of hidden in the background. So if you can ever see underneath or behind one of these chairs without setting off alarms, you should. Aalto also explored how a bent plywood form could relate to the arm and leg constructions that support it. So maybe the structure of the chair is geometric and regular, and we save the sort of curvy shape for the middle to establish a contrast. Sometimes those are straight pieces of wood, sometimes they're laminated bent wood. In 1935, with Ino and two other friends who had started out as clients of his, he established his own company called Artek to manufacture and distribute his furniture designs. At the time, nobody else could make these, so they started a company to do it. And then Ino worked as its artistic director and then became its managing director until her death. That company's still in business and still makes all of the Aalto furniture. On the left is the way the chair was made. Again, the side pieces are laminated wood, and the seat is a piece of bent plywood. And this is maximizing the movement you can get from that molded plywood by attaching it on the back side of those curves. And on the right is an exploratory drawing for how those side members might have been made. It's not the way they were made, but you can see that he's adding more layers where it needs more structure. In the end, the cantilevered arm wasn't strong enough, so he went for a closed loop instead. This is another Aalto innovation that will be known to you through an IKEA knockoff, which I guess is great. I'm looking to the side because I have one right next to me, which I'm not going to show you. This doesn't seem like much of a design, but if you stop and examine how it's made, it's a stroke of absolute genius. So this is a tree that was cut down and made into a board that was then sliced up to make veneer, that was then laminated together with glue to make plywood, but it still stayed a solid piece of wood also. The drawing on the right is from the patent, and you can see the bottom part is solid wood. The upper part has been cut into fins, and then veneer is inserted with glue and it's bent in place and clamped. Just to make sure this makes sense, I have a collage of images with the bench as designed before this was figured out on the bottom, so there are finger joints at the corner, and you can see this is joinery. It's going to be more expensive and weaker. And then on the lower right, you can see a progression of the wood being turned into the knee, and the video on the upper left shows this in action. Strips of veneer are glued and inserted into the slices in the leg, and then they're pressed in place. Then a whole bunch of these are put in a clamp at once, formed into place, and then left to dry. I don't know if I explained that well. I'm good at using a lot of words, but I'm not great at using words effectively, so hopefully that made sense. Aalto achieved international fame as an architect in 1939 for the finished pavilion at the World's Fair in New York. Frank Lloyd Wright, who was not inclined to praise other people's work, called this a work of genius. And remember, at global expositions, each country would try and show off its wealth, what it had a lot of. Material wealth, natural wealth, cultural wealth, manufacturing wealth, intellectual wealth. And this pavilion was trying to communicate a whole lot of things at once. The progress that Finland had made in design and manufacturing, but also the native beauty, the natural beauty of Finland. It's slats of wood making up curved, undulating walls, lit from behind with large photographs. So there's real estate there for actual information in the photographs and objects at the bottom as an exhibition, but overall it gives you a sense of the light through the trees and the forest. And this served as a great example of architecture doing more than merely housing something. It communicated an experience and a feeling at the same time. Both Ino and Aalto submitted different proposals for this competition. Aalto's was chosen, and then Ino worked on this with him, and as realized, it became a sort of hybrid of both of their proposals. Ino was an avid photographer, and I have to believe the incorporation of photography in here came from her. At any rate, it is credited to both of them, but it is the thing that at the time made Aalto super famous. Other designers were exploring this new material around the world. Gerald Summers and his company, Makers of Simple Furniture, is the best example in England of the early investigation of plywood. Alvar Aalto's furniture was featured in an exhibition that was organized by the Architectural Review in 1933, and this opened the eyes of English designers to the potential of laminated wood. I like looking at Summers' work to tease out what the thinking was. He's using plywood as a flat material, as a board material, and as something that could bend on one curve. Sometimes he's reducing the thickness and using thinner plywood for the bends and thicker plywood for the straights. Nevertheless, these are all tacos. All of this bending is happening on one axis, but they become really playful, inventive shapes in spite of that limitation. Somers started his company with his wife, Marjorie Amy Butcher, and at first they made the furniture themselves in very limited production. And they experimented with free-form designs. What could this wood become? This is their most iconic chair, which probably you have seen images of. This, I think, is the most form you could possibly get out of a chair that is still essentially a taco. The bends are happening in two different directions, but on the same axis. This is a totally brilliant business card produced by a furniture shop called Bent Ply in 2013. And I show it to you, one, because it's so cool, but two, it really helps you understand how this chair was made. It is one rectangle that's been very cleverly cut out of separate layers of veneer and then glued together and pressed into shape. Some of the techniques that Somers was thinking of were slightly beyond his ability to produce and create tooling for on his own. So in 1934, he looked to a British company named Isocon, which stood for Isometric Unit Construction. And this is a company that you might want to know more about. Jack and Molly Pritchard and Wells Coates, who designed a famous radio that I somehow forgot to show you, started this company together to introduce a modern aesthetic to England, especially with architecture and what they thought would be low-cost housing. Jack Pritchard took a job with a company called Venesta, which was veneer from Estonia, in 1925. Venesta was part of a company in Estonia that pioneered plywood and adhesives. And before Pritchard, they were using it as a substitute for solid wood. But Pritchard realized that the material's integrity wasn't being used well, and they could combine the material with new ideas about aesthetics and modernism and create something really meaningfully different. The stool on the right is something I hope you are familiar with and stay familiar with. It's a really beautiful example of anonymous design. We don't know who designed it. It was manufactured by Venesta and imported to England starting in 1933. It only weighs 2.5 pounds, it's 17 inches tall, the seat is detachable, and the sides are tapered. So the base can be stacked very tightly. Lots of them can fit in one small container. The seats can be stacked and then very quickly assembled. It's also incredibly strong because of the use of plywood. So this is a really beautiful example of an attractive, lightweight, inexpensive piece of furniture. I wish IKEA were knocking that off. Remember that there are two possible directions with plywood. You can use it in sheet form, or you can bend it and create something curved. Isocon explored both directions. They produced unit furniture with a comb joint in place of dovetails, which was better suited to plywood, and created flat pack, inexpensive shelving. Remember, this is 1935, way before IKEA was doing this. And I think they also, as IKEA does, I suppose, were careful to design an object that was anonymous enough that if you use them around the perimeter of a room, you could really create a pretty complete aesthetic with just a handful of parts. When Marcel Breuer moved to England to escape the Nazis, he fell in with Wells Coates and the Pritchards, and they invited him to design for Isocon. His long chair, which had originally been designed in Germany in aluminum, was translated into wood. And this was called the long chair because it's 56 inches long, but it was lightweight because of the plywood. I don't think there's a lot innovative about the smaller stacking tables, but when you see what Breuer introduced to the underside to give this the strength it needed, it starts to be a pretty appealing material investigation with these extra strips. The bent plywood component of the long chair was made by Luther in Estonia and then sent to London for Venesta to use, and the side pieces were handmade in London out of laminated strips of wood, oftentimes recycled from the shipping crates that came from Estonia. Although lightweight and relatively affordable, it was about 3 pounds, the chair proved difficult to make because of the joinery required, and it was pretty quickly reimagined using plywood as a flat material, giving you the same shape and body support, but a completely different and easier construction system. Another object that Isocon produced was Egon Riis's penguin donkey. You will never get a chance in your life again to say penguin and donkey in the same phrase, so take advantage now. This is a piece of furniture called a donkey because it has these saddlebags, the two sides in which you can put books, and Penguin comes from those books being published by Penguin. If you collected enough coupons from the Penguin Modern Classics line, you could get a penguin donkey. It's a really nice example of a form that comes out of investigating what bent plywood could do. It was not available for long because World War II cut off plywood parts from Estonia, and then it wasn't revived until 1963 when Ernest Race redesigned it, this time using flat sheets of plywood and creating an aesthetic more in line with the 1960s. FYI, I discovered on Instagram a wonderful company called Isocon Plus, which is in operation today to revive all of these designs and put them back into production. And they've designed a third version of the Penguin Donkey, which is now just called Donkey 3. That's more in line with today's interests in form. I'm cheating and putting Bruno Matheson in here because I love looking at his work. He was a Swedish architect and furniture maker. And really these chairs are using laminated wood for the sides and then webbing for the center. So they don't count as plywood investigations, but I'm letting them in because they are part of the larger conversation of today, and I kind of want you to see the remarkably beautiful shapes that were possible because of the bent wood. Matheson was interested in creating forms that would give complete contact and as a result, more comfortable support to the body. He also added reading stands wherever possible. So maybe I'm just including this because it is my dream to be delivering this lecture in a lounge chair with my laptop on a reading stand. Dream big, Matt. If we go back to planes and World War II, a lot of things changed, and that gets us to the next big chapter for plywood. Wooden planes had fallen out of favor in the 30s because we got so much better at using aluminum, but the war changed that. In World War II, we saw an explosion of plywood planes, partly because plywood advances allowed us to do that, partly because we needed fast, inexpensive planes. We didn't need them to last for decades. We needed them to get up in the air and drop some bombs and shoot some bullets. De Havilland created the Mosquito plane using a sandwich construction with a balsa core and then veneer on either side. And Beechcraft airplanes in Los Angeles also helped advance forming wood in America. There was a dramatic need for more planes and also for more boats, certainly big boats to go across the ocean, but even more small, fast coastal explorations. Plywood was the perfect material for this. You could lay up veneer in different directions into an open face mold, and you add the transom and you have a complete boat that's essentially two parts. Advances in plywood during the war also lead us to the story of Charles and Ray Eames. So the other video that I'm posting this week is their story in full. I'm only including in this conversation a couple of key points about their plywood investigations because they advance this narrative so completely. Charles Eames had been working with Eero Saarinen at Cranbrook to explore how plywood could be used in seating. And their big break came with the Museum of Modern Art's announcement of a competition for a 1941 exhibition called Organic Design in Home Furnishings. Eames and Saarinen decided to work on figuring out how to mold an organic shape. This is molded plywood, not bent plywood. It is a potato chip, not a taco. They had really limited success. When they bent the wood in an extra direction, of course, it started to crack. So all my students already know the answer to what you do when your prototype is failing. You either paint it black or cover it with fabric. They chose the second approach. So on the inside of the small chair where the cracks were more visible, they added a pad and upholstery, and on the larger, more complicated chairs, they covered the whole thing. Fortunately, Marley Ehrman was at Cranbrook making fabric, and they could use some of that to solve their problem. There's a lot more to talk about with that chair and that project. Check out the Eames video for that. Charles met Ray Eames at Cranbrook, and after they left Cranbrook, they moved to Los Angeles, where Charles got a job at MGM, and he pilfered wood and glue from the lot and brought it home to the apartment, where Ray experimented during the day while he was at work with equipment they set up in their guest room. This is the machine they made in the guest room of their apartment that provided the heat and the clamping for their plywood experiments. They called it the Kazam machine because of the noise it produced in use. So it had a plug, you plugged it in, and the electric wires in the bed created heat, probably not the safest thing, and then the lid clamps shut, and a bicycle pump inflates a bladder inside and puts pressure on the mold. This allowed Charles and Ray Eames to start exploring what they could do in terms of forming plywood. Amazingly, This is the technology that Ray Eames had available to produce her plywood studies. These were sculptures that were produced to explore the limits of bending and molding plywood to create three-dimensional form. They're profoundly beautiful, but they're not really repeatable. These were exercises. These were studies. The Eameses realized quickly that they wouldn't be able to really make the progress they wanted to make in understanding plywood without access to better materials. And during World War II, the only people who had access to the materials were the military. They got a contract with the Army to produce a lightweight, inexpensive leg splint, and this allowed them access to wood and glue and an order for 5,000 leg splints by the end of the project. If you ever get a chance to see one of these in person, look as closely as you're allowed to at where the seams happen. In the bottom, you can see a layout of all the different die-cut parts. So the veneer is run through a die cutter, which uses steel blades to over and over again smack the veneer and cut it into shapes. And each layer has a joint in a different place, so when it's all glued up, it has strength everywhere, but also maximizes the amount of three-dimensional form that can be made out of flat pieces of wood. When you add glue and heat and pressure, you get a finished leg splint with essentially one process. At this point, the Eameses knew the specifics of three-dimensionally molded plywood construction inside and out. And they became the go-to people for anyone who was exploring methods of molding three-dimensional plywood forms. But after the war, they were really ready to hit the ground running and turn their understanding of three-dimensional molding of plywood into production furniture. The Eameses were brilliant at multiple iterations, and they produced an office full of trials to figure out how three-dimensionally molded plywood could hold a person up. Charles was once asked, "Did you think of the Eames chair in a flash?" And he replied, "Yes, a sort of 30-year flash." One of the challenges was trying to figure out how the seat and the back could be made in one shape. The challenge of creating a unified back and seat proved too much for the plywood, but their multiple investigations show all of the ways you might try that. Splitting the back in two to create more form, but then joining those two together so you don't get movement that would pinch the back. As the splint did, leaving openings where the form has to really change axis or direction. In the end, they arrived at a chair that had separate back and seat, and then another structure that held those two parts where they needed to be, in either laminated wood or metal. And here we go, the potato chip. This is not a taco. This is molded plywood, not bent plywood. It's changing in every direction on every axis. The Eameses essentially liberated the wood, making it three-dimensional, leaving the grain visible, making the form they arrived at the decorative aspect of this chair. They didn't need to drill funny words or fancy patterns into this. The plywood parts were molded in about 10 minutes each, and then hand finishing was minimal, sanding and lacquering, so the prices were intended to stay low. They made the first 5,000 of these chairs in their own office, and then created the tooling that went on to produce the first 50,000 of those once Herman Miller took over production. By 1951, they were selling 2,000 a month of this chair. And this chair has stayed a celebrated piece of design history. Interestingly, they also produced a bunch of radio housings that are not celebrated. They sold 200,000 of these radio housings between 1946 and 1952, and yet we don't remember the Eameses as radio designers, and I think you can see why. The Eameses' understanding of plywood led to the creation of one of their most famous objects, the elephant stool. And yet they only made 2 of these. So how did this become one of their most iconic objects? It's so famous that Vitra has reproduced it in plastic, which makes me kind of crazy because the whole reason this looks the way it does is understanding what the wood will allow. The forms come out of the material, so to reproduce it in plastic is wrong. Why are they remembered for this elephant, which there were 2 of, and not for a radio that there were 200,000 of? Because of the success of this material investigation and the celebration of the forms they arrived at. All throughout World War II, people were doing research and improving glue and changing what plywood could be and where it could be used. There's really no reason to show you this except that we spent so much time already looking at Donald Deskey. I thought I'd bring him into yet another lecture by pointing out that during the war he patented something called Weldtex. And the idea is one I think we can learn from. He realized that the outside surface of plywood had to have an expensive wood on it to look good. And this is an investigation of the opposite equation, which is putting a thick layer of really cheap, crappy wood on the outside and then striating it, cutting the whole surface, so that as it aged and moved and cracked, it wouldn't matter. Intentionally distressing this surface to make something that in the end is visually sort of exciting and rich looking. And this relatively inexpensive and durable material ended up really transforming a lot of building after the war. In the 60s, it became a surface that people would install in their houses to update them. Why have that old 30s or 40s house when you could have a new 60s house by just slapping this wooden surface on the walls? After the war, the newfound mastery of plywood opened all sorts of doors for designers, and around the world, we saw the taco graduate into the potato chip. We saw people exploring what kind of forms they could make using molded plywood. Hans Piech was a student of Mart Stam's. He made the Lawu chair, the laminated wood chair, as a senior project when he was in school. So take that, sophomores, get busy. He started his own company to make these, and then in 1948 moved to England, where they were revised and produced. So there are a couple of different versions of this chair. If we go to Denmark, we get to one of the most famous and successful examples of post-war plywood use. Arne Jacobsen is Denmark's best-known architect, and he was able to introduce modernism and add a sort of sense of nature in a way that really reflected a Danish sensibility. Plywood is a really important part of how he did that and of his success. He had visited Paris to see the 1925 exposition, the Art Deco Expo, and he won a silver medal there at the age of 23 for his woven rattan furniture. So if I showed you this furniture on the top and said, look at this award-winning furniture, you would laugh and say, pair one. But if you compare this to the other things that were on view at the Art Deco exposition, there's a whole different thing going on here that really is a celebration of geometry, but with a heavy dose of nature still present. He saw Corbusier's Esprit Nouveau Pavillion at that exhibition. He then traveled to Berlin and discovered Mies van der Rohe and Gropius. Those experiences, plus also seeing Charles and Ray Eames's post-war work, led to a new modern approach to furniture, and his furniture work defines plywood in the 1950s. This is the ant chair, which has 3 legs and a little teeny pinched-in waist like an ant, and the even more famous Series 7 chair. And this is a movie that Fris Hansen made of how that chair is produced. And I'll let this play while I describe what's happening. Layers of veneer are clamped together, and a template is used to cut out the profile. They're run through a gluing machine, and then layers of the wood with the heat-activated glue are stacked up. They're put into a mold. That mold is closed, and then heat and pressure are applied. And when it's opened, a number of minutes later, you have 90% of a finished chair. Those parts are then put into a multi-head, multi-axis routing machine that cuts the outside profile and finishes the edge. And don't you wish we had one of those in the wood shop? Edgar Kaufman Jr. at the MoMA wrote in 1950 in his What is Modern Design, "The simple declaration of the real form of the material succeeds in revealing a practical, uncomplicated, sensible beauty." It's really easy to see that in the Series 7 chair. It is one of the most popular chairs of the late 20th and early 21st century. Over 5 million have been sold since 1955. It also is one of the most knocked off chairs ever made. And you have seen versions of this chair all over the place, including at IKEA. Jacobsen also went on to design the SAS terminal and hotel in Copenhagen. He designed his swan and egg chairs for that hotel. He designed everything for that project, including ceramic ashtrays that they sold at the souvenir shop and the stainless steel cutlery that was used in the hotel. I am pretty fussy about my forks, and this is not a winning fork in my book, but it's a pretty remarkable and fully formed aesthetic. So fully formed that although it was created in 1957, Stanley Kubrick used it in 2001: A Space Odyssey because it was so futuristic looking that it would be believably 2001. I'm going to do a terrible job talking about Hans Wegner. He was a student of Arne Jacobsen's. He started his own company. He wanted to strip the old chairs of their outer style and let them appear in their pure construction. And if this were a furniture history class, we'd stop for a long time, because his ability to integrate craft and traditional woodworking techniques into a modern and particularly Danish aesthetic is really exciting. I only have one slide of his work here because he also explored what plywood could do to create an aesthetic and make a chair. If we go to Italy, Carlo Morlino was exploring bent plywood, and I'm not sure if he arrived at molded plywood. He had some really complicated shapes, but they kind of seem to me like very fancy tacos. Nevertheless, it's a really complete aesthetic that's pretty unique to him. He was an Italian architect working in Turin, and he wrote, "Everything is permissible, as long as it is fantastic." Much of his work combines carved pieces with molded or bent pieces, laminated pieces with solid pieces. There's a pretty complete combining of different techniques. It's like, what if August Thonet and Charles Eames had met and then moved to Italy? And because I know some of you will want to see this, he designed a car that he had made to race in the Grand Prix in 1955. It didn't end up finishing the race, but it's a pretty lovely form. Also in Italy, Osvaldo Bersani was exploring what plywood could do, and I feel like a lot of these explorations are similar looking because there are only so many places you can go with this exploration. So look for the similarities in how people are dealing with making a completely three-dimensional form. Where are you relieving the wood to avoid cracking, and how much three-dimensional form can you get? Vittorio Nobili did a beautiful job creating a complete seat and back out of one molded form. And Luciano Nustrini used the least amount of wood possible to make something called a chair. If you go back and look at the Eames studies for their chairs, you will see all of these forms. That doesn't mean that these are copies of what the Eameses did, because all of their studies lived in their studio until it was emptied out decades later. So I think it's actually really good evidence that creative people exploring innovation will end up arriving at similar answers. The exploration continued in America as well. Ray Comai's chair is one of the more remembered ones. I recently got to see the undersides of it at Wright's Auction House in Chicago, and bless them for letting me turn it over. Because one of the interesting struggles with all of this furniture is how to attach the wooden seat to the metal legs. There has to be something in between. In the Eames chairs, it's a little rubber mount. Everybody invented a different way to do this, some more successfully than others. And Comai realized that a large glue surface would be the best thing. So there's a big piece of solid wood glued onto the plywood, and then the metal tubing slides into a shaped groove and is screwed in place. Also, I had never thought about what is the hardware that holds the two halves of the back together, and that's a really beautiful detail on this chair. I'm not even going to try and pronounce these two exquisitely Polish names, but there were people in Poland exploring this as well. And the chair on the left is the Płuca chair, which is the Polish word for lungs. You can see in the form why that might be the name for this chair. Sori Yanagi was a Japanese designer who knew the Eameses, and his exploration produces not only a really beautiful form, but a really smart piece of manufacturing. It's one shape, a pretty beautiful potato chip, molded in every direction, used twice. It's just attached to the top and then a spacer at the bottom. So it's a small amount of work for a pretty enormous amount of stool. Junzo Sakakuro had worked with Charlotte Perriand at Corbusier's office in the 1930s, and Perriand and Sakakuro were lifelong friends. He was also working in Japan and exploring how to incorporate plywood into his work. Another Danish designer who was exploring the limits of what plywood could do is Grete Jalk, who made this really extraordinary chair. It was very difficult to make. Only about 300 were made. If you try and imagine how the veneer is fitted into a mold for this, good luck to you. Fortunately for us, it was put back in production in 2008, along with the nesting tables that had been designed but not realized in their day. Robin and Lucian Day are often called the Charles and Ray Eames of England, which is so unfair to everyone involved. But I understand why people do that. This is another husband and wife team who transformed design in their day, in their country, but globally as well. The similarities are that they were husband and wife teams who transformed design, producing textiles and furniture. The differences are that Charles and Ray Eames worked together, and Ray oftentimes disappeared into that work, and we don't know what she did. Robin and Lucian Day did not work together, they worked at the same time. Lucian Day was a textile designer, and Robin Day was a furniture designer. But they were on a similar trajectory to the Eameses in that they helped transform post-war aesthetics and introduce modernism in a comfortable and accessible way. Robin arrived at a different aesthetic in his plywood investigations because I think he was less interested in really pushing the boundaries of what the wood could do and was more interested in creating an intentional aesthetic and providing furniture that was affordable at a time when England really needed that. So there's just a different equation happening. They both got their big break with the Festival of Britain in 1951. Lucienne Day produced the Calyx fabric, which launched her really huge career in textile design, and Robin created some of his first successful chairs. For me, Day is not such a part of the plywood story, although his plywood chairs were made in huge quantities and really did influence people, because his work in plastic was so extraordinary that it overshadowed everything else. The polyprop chair was one of the first injection molded pieces of furniture. It's made of polypropylene, it's a stacking chair with a metal base, weighed only about 3 pounds, and over 20 million have been manufactured. This chair really changed the way people thought about production furniture. I love the image on the right because it's Robin Day in Botswana in the 80s, seeing that dugout canoes had been retrofitted with old polyprop chairs as their seating. And I think that picture just speaks volumes about the success of this chair. Even when they broke, even when the legs gave out, they still had utility in them. And Day's later chairs, made in UV-resistant plastic, completely transformed stadium seating. As time went on, manufacturing tolerances improved. We were able to make molded plywood parts more predictably, and they started to appear in ever more places and in ever more designs. David Rowland's 40-in-4 chair is a great example. Created in 1964, originally with plywood, later with plastic panels, and they're named this because you can stack 40 in 4 feet. I don't think they're as beautiful as an Eames chair or even a Robin Day chair, but they're doing something very different. These are designed to be lightweight, durable, stackable, clip-togetherable, and create group seating quickly. And as a result, these ended up in offices and schools everywhere. So here we are finally at the end of all of this, managing to make things in large volumes with rationalized, effective manufacturing, while also making those things gorgeous. Some of them were expensive, some of them are affordable, but we're really starting to understand the equation better and control the variables. The secret that took so long for us to figure out is that form is ornament. Everything else we looked at this semester had ornament applied to it somehow. Suddenly we have things that are beautiful only because of the shapes, not because of the surfaces or the patterns. We figured out that manufacturing processes and materials need to be considered as part of the design process, and that can, and I would argue should, inform the aesthetic of the final object. So watch the video about the Eameses, which is part 2 of this week. Next week, we will finish up this strange collage experience with 2 more chapters, one that looks at the focus on the home after World War II and examines how utility plays a role in the form story that we looked at today. And we'll also look at the workplace. The era of the workplace and the corporation starts to affect design and create new designs for office and for work. There you go. Okay, see you. Okay, later, dude. To take advantage of that menu. Plywood and airplanes arrived at about the same time, and they were yawning break, I'm gonna yawn now. And that's partly because plywood plus ukulele plus plywood plus canoe plus published sheet music plus picnic equals popular song. And the chair on the left is, I don't know why that chair is here. That chair is just here because I needed to put 2 chairs on this slide, but there's really not anything to say about it. He designed furniture which explored material potential, potential. Joining Zoom a little late to finish. Do you always talk out loud when you text? Yes. I can't text without talking out loud. Joining Zoom a little late to finish recording lecture. Boom, boom, boom. Send. Okay. Movement. The movement. Oh. The movement. Oh. The movement. The movement. The movement. Oh. The movement. Oh. Oh. Oh my God. I'm never gonna finish.